guys, so today we're going to be talking about simplifying radicals. So a couple things that we want to talk about before we get going is we want to talk about some definitions of some things, okay? So one of our first definitions is going to be radical expressions. Okay, so we want to simplify a radical expression. Now a radical expression is any expression or an expression that contains a square root, this little guy right here, symbol. Okay? And we like to call that little square root symbol a radical. Alright? So a radical expression is anything that contains that square root symbol. Alright? And a radicand, which is kind of a funny word here, is the expression under the radical. Okay? So what we want to do is we want to simplify our radicand. Alright? So guys, in order to simplify a radical expression, it must meet 3 criteria. Okay? So to simplify, we're simplifying radical expressions, 3 criteria must be met. The first criteria is that the radicand, or the number under our radical, has no perfect square factors other than 1. Alright guys, so in order to simplify a radical expression, the first criteria is that the radicand has no perfect square factors other than 1. If it has more than 1 perfect square factor, it is not simplified. Okay? The second criteria that must be met is that the radicand, the number under our radical, has no fractions. Alright, so that's our second criteria that must be met. And the final and third criteria is that the denominator does not contain a square root. Alright? So the denominator does not contain our square root. Now 2 properties that will help us significantly when we are working through some of these options here is the product property. That's not how you spell property. Sorry guys. The product property of square roots. Oh man, I'm struggling. Sorry guys. The product property of square roots. And then over here we have our quotient property of square roots. Alright, so we're going to talk about these 2 different properties that are going to help us when we simplify. So the product property of square roots is where we have if we have a times b, we have 2 factors under a square root, we can separate that into radical a times radical b. So the square root of a times b is equal to the square root of a times the square root of b. Are you guys comfortable with that? The quotient property of square roots is very similar. It tells us that the square root of a divided by b is the same thing as the square root of a divided by the square root of b. Okay? So our product property of square roots tells us anything, if they're multiplied by, it's still good. I'm going to go ahead and fix that so it looks a little bit better. There we go. Okay? There we go. That looks better. Okay? You guys feel good about these two properties here? Y'all feel good about that? So what I want us to talk about is I want us to talk about some perfect squares, okay? Now, when we are identifying perfect squares, we are thinking about numbers that you can take the square root of perfectly. So if I was going to write a list of my perfect squares, and guys, I highly, highly, highly recommend start committing these to your memory. All right? If not, you can keep a list handy that you can reference, but these will be very helpful. 1 is a perfect square because the square root of 1 is 1. 4 is also a perfect square. 9, 16, 25, 36, 49, 64, I'm going to keep going here, 81, 100, 121, 144, 169, 196, and 225. Now guys, I went all the way out to 15. Hopefully a lot of these are recognizable to y'all, at least up to 144, right? Because of knowing your times tables from when you were younger, right? The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6, the square root of 49 is 7, the square root of 64 is 8, the square root of 81 is 9, the square root of 100 is 10, the square root of 121 is 11, the square root of 144 is 12, the square root of 169 is 13, the square root of 196 is 14, and the square root of 225 is 15. So guys, hopefully you guys can recognize those as perfect squares. And what is nice, guys, is even if you can't remember that, guys, does everyone know how to find the square root button on their calculator? You do second, and then you hit that little x squared button, and you are given, I'll show it to you guys. See this little x squared button? You hit second first, then you hit x squared. So let's say I type in 225. Well, guys, it gives me a perfect square. It is when you take the square root of it, and it is a perfect whole number. Got it? So there are obviously more perfect squares out there, but guys, I highly recommend having these 15 committed to your memory. Cool? Because that'll make life a little bit easier. So for example, if we are going to do a couple little examples right here, all right, if I wanted to take, let's see here, example 1, if I wanted to take the square root of 25, what would that be? What's the square root of 25, y'all? It's just 5, okay? When you take the square root, it divides perfectly into a whole number. All right, number 2, we're going to look at this guy right here. I'm going to take the square root of 169. What's the square root of 169, y'all? 13. Y'all feel good about that? Okay. Now, guys, even if you couldn't remember this, you could always go in here, do square root of 169, and you get a perfect number of 13 there. Okay. Now I'm going to change it up a little bit. All right. For number 3, I'm going to give you 2 times the square root of 144. Well, guys, what is the square root of 144? 12, right? So if we followed with our perfect squares here, so we have 2 times 12. So what is that going to give us? 24. Do y'all see that? So I took the square root of 144 and I got 12. Y'all feel good about that right there? So these gave us nice little perfect numbers, right? Now if we wanted to, we could also see something if we had, for example, I'll do a 4th example real quick. I'm just kind of riffing here. If we had like the square root of 36 over 25, we could rewrite that as the square root of 36 divided by the square root of 25. And what does that give us? 6/5. Do y'all feel good about that so far? If they're perfect squares, then they come down perfectly, all right? It's very, very nice when we see that here, all right, guys? So these are some examples of what happens when we have our perfect squares. However, this is not always the case. So now I want us to work here. We're going to go to our second page. And guys, keep this perfect square list kind of handy for you to see. I also have it up here on the board. Do y'all see it in the purple up there? So you guys can see it up there on the board. All right? So, because this will help tremendously with our simplifying, okay? So, we are going to simplify these radicals, okay? So, the first method that I want to teach you is through the perfect square, okay? The perfect square method, all right? Or I guess, I don't know why I have method 1 is the perfect square method, okay? So I guess I should have said the first method is the perfect square method. All right, guys? So how we're going to do this with our perfect square method is I'm going to give you guys this right here. We're going to say number 1 here. We are going to try to find the square root of 24. Well, guys, if we want to find the square root of 24, can we separate it into factors where it has a perfect square factor? So what is a factor of 24 that is a perfect square? 4. 4 is a perfect square. It's on our little list of factors of perfect squares here. Kind of keep that up there. If you guys just want to write the perfect squares up at the top of the page, you can do that too. 1, 4, 9, 16, 25, 36, 49. Right? You can just kind of write that up there so that you guys can remember these are all of our perfect squares. All right? I'm going to do it real quick. 81, not 1,000. There we go. 121, 144, 169, 196, and 225. So these are all of our perfect squares. Lovely. Okay, that can help us remember. And yes, the perfect square that is a factor of 24 is 4. So guys, I recommend writing this out with the perfect square first, okay? So we can rewrite this as 4 times 6. Are you guys okay with that? 24 can be written as 4 times 6. So if I rewrite that as 4 times 6, that can be written as radical 4 times radical 6. Are y'all comfortable with that? Well, guys, what's the square root of 4 again? 2. So this just becomes 2 times the square root of 6. And that is our final answer. Okay? Because, remember, it has to simplify a few things here. The radicand, the number under your radical, can have no other perfect square factors. Right? Does 6 have any factors that are perfect squares? No, it's 2 and 3. So those aren't perfect squares. So that satisfies. It can't have any fractions, and it can't have a denominator. So it satisfies everything. Also, you can kind of check yourself. You can go here and you can say, okay, the square root of 24 is this irrational, long, nasty-looking decimal. Well, guys, we said that the square root of 24 is actually equal to 2 radical 6. So, guys, if I do 2 times the square root of 6, it gives me the exact same nasty-looking decimal. Do y'all see that? Because they're equal to one another. This is just the simplified version. Do y'all see that? This is our simplified version. Okay? So let's look at another method here, okay? Another example. Number 2. All right, guys? When we look at number 2, I want us to take the square root of 63. All right, guys? So if we take the square root of 63 right here, let's look at this. The square root of 63. What is it? Does 63 have a perfect square factor? Okay, well, we're struggling. Well, guys, let's look at our perfect squares. 1, 4, 9, 16, 25, 36. Obviously, it's got to be less than 63. Well, guys, is 63, not 64, is 63 going to be divisible by 49, y'all? No. Now, you can check yourself. You can say, okay, 63 divided by 49. No, it's not. Okay, is 63 going to be divisible by 36? No. Are there any numbers that you guys can see that will actually work here? Really? 63 divided by 25? I heard somebody, 63 divided by 16. Nope, nope, nope. Okay, guys, what about 63 divided by 9? Oh, ding, 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 ding. We have a winner, okay? So, guys, also, factors of 63 are 7 and 9, right? So, guys, we want to put our perfect square factor first. Are you guys comfortable with that? Our perfect square factor goes first. So, that's 9 times, square root of 9 times the square root of 7. Well, guys, what's the square root of 9? 3. So that's the whole reason, guys, we're looking for perfect squares. So this is really the same thing as 3 times radical 7. Do y'all feel good about that? So we're just simplifying. It's the exact same thing. Okay, guys? I want to do 2 more examples for y'all with this first method so that we can feel really good about it, okay? So 4, let's do the square root of, let's do 92. Are you guys okay with that? Let's do the square root of 92, all right? So our square root of 92 here is going to be, let's look at this. So what is a perfect square factor of 92? Can anyone help me out? Yep, I hear your calculator's working. So 92 divided by, I don't know, 92 divided by 64? No, that doesn't work. 92 divided by 36? No. Oh, what do we got? 4. Okay, 92 divided by 4. So we got 23 and 4. So guys, I'm going to rewrite that as the square root of 4 times the square root of 23. Okay, guys? So that's the square root of 4 times the square root of 23. Well, guys, what's the square root of 4? 2. So that's 2 square root of 23. Do y'all feel good about this so far? Okay, excellent. Okay, now let's take a look at number 4. Or number, why did I do, oh my goodness. I'm a math teacher. That was number 3, wasn't it? This is number 4. All right, here we go. Now 4, I want us to actually do -3 on the outside times the square root of 192. Okay, so now we have 192, not just 92. Okay, so does 92 have any perfect square factors that work? Does 192? Let's see here. 192 divided by 36 maybe? No. So you guys can just kind of go through the line, right? 192 divided by 4 works. All right. Are there any other perfect square factors? 16 works. Okay. 192 divided by 16. Okay, let's do that. Are you guys cool with that? You guys want to do 16? Did anybody else find another one? Yes, ma'am? 64. Okay. I like this one because you could go 2 different ways. Okay, so we're actually going to do this one twice because I want to show you that it can work a couple different ways. All right? So check this out. If we do 16, are you guys cool doing 16 first? So what's 192 divided by 16? 12. All right. So we're going to say 3 times the square root of 16 times the square root of 12. Are you guys cool with that? Okay. So we're going to do it like this, where we have 3 times the square root of 16 times the square root of 12. Well, guys, what's the square root of 16? 4. So this becomes -3 times 4 times the square root of 12. Well, guys, what's -3 times 4? That's going to be what? -12 times the square root of 12. So, guys, are we done? It says the radicand. Is this divisible the number underneath our radical, is that divisible by any other perfect square? It is. So we're not totally simplified right here. Because what other perfect square goes into 12? 4. So guys, if we rewrote this as negative 12 times 4 times 3, right? Because we're not done. Because 12 is 4 times 3. Negative 12 times the square root of 4 times the square root of 3. Well, guys, what's the square root of 4? 2, right? So this becomes negative 12 times 2 times the square root of 3, which is really negative 24 times the square root of 3. Now, guys, that's a lot of steps, isn't it? So if you don't pick the biggest perfect square, you can still get the answer, but you have to keep simplifying. Does that make sense? You can't just stop here. You have to keep going. Now, one thing that Andrea pointed out was negative 3 times the square root of 192. She found that 64 is also a perfect square and was a factor of 192. So she found that 64 is divisible by 3. So guys, check this out. She found that if we could rewrite this as negative 3 times the square root of 64 times 3, because 192 can be broken up between 64 and 3. So now, what's the square root of 64? Anybody? 8. So that's negative 3 times 8 times the square root of 3. Well, guys, what's negative 3 times 8? Negative 24 times the square root of 3. So do y'all see? So now, can 3 be divided by any other perfect square except 1? No. So guys, we got the same answer, but if you don't pick the biggest perfect square, it's just going to take you a lot more steps to get there. Does that make sense, y'all? So I highly, highly recommend going back to your perfect square list and trying to find that biggest perfect square. Do y'all feel good about this so far? Okay, awesome. Now what I want to do is I want to show you guys a different method, okay? I personally like the perfect square method. The only problem with the perfect square method is if you don't pick the biggest perfect square, it kind of takes you a long time. Does that make sense, y'all? But it's not too bad if you can identify the largest perfect square. And guys, remember, this gets a little tricky because remember, we can test our answers by saying negative 3 times the square root of 192. It gives us this nasty looking decimal. And guys, if I type in this part right here, if we stopped at this step and we didn't keep simplifying, well guys, it still is equivalent. It's just not simplified. Does that make sense? So you have to make sure you simplify it. The final answer that's completely simplified is that negative 24 times the square root of 3. All three of those are equivalent to one another, but this is the only one that is simplified, this negative 24 times the square root of 3. Okay? So another method and that I want to teach you guys is the factor tree method. Okay? So we're going to do method 2. Okay? So our second method is the factor tree method. Okay? Now some of you guys might prefer this. Okay? Now on your homework, the first 6 problems, you're going to have to do it the perfect square method. Okay? But some of you guys might prefer this factor tree method. Okay? So what I want to do is I'm going to redo problems 1 through 4, but I'm going to do them with the factor tree this time. Okay? So we're going to get the same answers. So I'm going to call this one 1b. Are you guys cool with that? 1b. So we're going to do the square root of 24. So we already know what the answer is because we did it up there. But I want to show you guys this cool factor tree method. So how this works is, guys, y'all remember doing factor trees in middle school? So how we do this is we want to take the factors of 24. What are 2 factors of 24? 2 and 12. You could have picked 4 and 6, right? We want to get down to our prime factors, okay? So we have 2 and 12, okay? What else do we have? Are you guys good with 2 and 6? Are y'all cool with that? And then finally, I'm going to go 2 and 3. Now, guys, our final factors, those factors that we pull out are the ones that have nothing underneath it. So we would pick out 2, 2, 2, and 3. All right? So I'm going to rewrite this guy as 2 times 2 times 2 times 3. Are y'all comfortable with that? So we're going to rewrite this. And with the factor tree method, what you want to do is you want to write out all the factors, not just perfect square factors. You want to totally break it down. And then you want to find partners to pull out. Okay? So in here, if you find 2 things that are the exact same partner, like this, 2 and 2, these are the exact same little partner, then we can pull it out. But when you pull it out of the radical, you're just left with one of them. They like morph into each other and they just become one. It's like when 2 best friends just become totally identical, like they're one person, all right? So these 2 best friends have become one person now, okay? So we take out our 2, and we're going to take that guy out. And what are we left with under the radical? 2 times 3. Well, guys, 2 times 3 is going to be, 2 times 3 is going to be 6. Is that the exact same answer we got above? 2 radical 6? Yes, it is, all right? So you can do it this way with your factor trees by finding your pairs, okay? So if you have a really, really hard time finding that perfect square, this factor tree method will work every time, all right? So let's look at 2b, all right? We're going to try number 2 the same way here, all right? So 2b, we're going to take the square root of 63, okay? So what are some good factors of 63? What do we got? 9 and 7. That's all we got, right? Can we break down 9 anymore? We sure can. That's 3 and 3. Can we break down 7 anymore? No, that's just 7 and 1. So we have 3, 3, and 7. Are y'all comfortable with that? 3, 3, and 7. So I'm going to rewrite this guy as 3 times 3 times 7. And then we want to find the partners. Good night. All right. We want to find our partners. Pull out your partners. They become 1. That's 3. And then what are we left with on the inside? Just radical 7. Okay? So you can find your partners and pull them out. We get the exact same thing we got above. Do y'all feel good about that? So these are 2 different methods for doing this. I want to do the other ones too because I think they're good. All right? So let's look at we're going to do 3b. All right? So 3b, we're going to say is the square root of 92. Well, how can we factor tree 92? Ooh, I like that. 4 and 23. You also could have done 2 and 46, right? Whenever I see an even number, I'm like, divided by 2, divided by 2. You can do that every time, right? So we got 4 and 23. We also have 2 and 2. Are you guys comfortable with that? So we can rewrite this. We found, can 23 be divisible by anything else? No, that's a prime number, isn't it? I love prime numbers. All right, guys. My daughter was almost born on the 17th, but she wasn't. And that's okay. But I was really excited because I was hoping that she'd be born on a prime number day. All right, so then we got the square root of 2 times 23. So we're rewriting 92 like that. We find our pairs, and we pull it out, and we have 2 times the square root of 23. Do y'all feel good about that? So either method is totally acceptable, but it just kind of depends the way it works in your mind, okay? Now, if we like, now I'm going to do my final one, 4b. This one's a good one. -3 times the square root of 192. So guys, we got to find all the factors of 192 here. Can you guys help me with that? Let's see here. You guys good with like 2? You guys just cool doing dividing by 2 because it's an even number? So that's what, 2 and 96? And then 2 and 48. What are good factors of 48 here? 6 and 8. Are you guys cool with that? Or you could have done 2 and 24. Okay, 6 is 2 and 3. 8 is 2 and 2. Man, no, that's not right. What is 8? 8 is 2 and 4, right? Got ahead of myself. And then 4 is 2 and 2. Dang, we got a lot of factors, don't we, on this guy? So let's see here. We have 1, 2, 3, 4, 5, 6 2's, and 1 little 3 left behind. So I'm going to have to rewrite this as -3, the square root of, we need to do 6 2's, 1, 2, 3, 4, 5, 6, and a 3. Y'all good with that? Okay. Now we want to find our partners. So we have one set of partners we're going to pull out. Another set of partners that we're going to pull out. And lastly, a final set of partners that we're going to pull out. So we are going to have -3, because that's still on the outside, times 2, times 2, times 2, because we did it 1, 2, 3 times. And what's left on the inside here? Just radical 3. That's the only thing that's left on the inside. So now we look here and we say, okay, -3 times 2 times 2 times 2. So that's 6, 12, -24. Let's see here, just double check. Yep, -24. So that becomes -24 radical 3. Okay, guys? So these are 2 different methods for how we simplify fractions. How do y'all feel about this so far? Is that not too bad? Okay. I have one more. And guys, so it does not matter to me which method you pick. On the homework, on the first 6 questions, you have to do it the perfect square method. But on the rest of them, you can do it with your factor tree if you want, okay? But I want you guys to at least try to practice doing the perfect square method. But do y'all see the benefits in both of them? Okay? Sometimes if you can't pick out a perfect square, then just factor tree it, and it'll work every time. But it does take a little bit longer. Do y'all see that? It does take a little bit more time. Okay, last little thing that we're going to do today, okay, is I want us to talk about dividing. What happens when we have division? I'm sorry I couldn't fit it on that page. I just took up a little too much space. So we've done, I'm going to do numbers, I guess we're just continuing, all right? So this is example number 5 here, all right? And I have, let's say, it's the square root of 2 over 72. Well, guys, can we simplify that? How can we simplify that? What is that going to simplify into, y'all? What is it? We could do the square root of 2 over 72, but we probably want to simplify the fraction first, right? Because look what happens. Can 2 and 72 simplify at all? Maybe. Okay, so we could do this 2 ways. We could do it like Alex suggested, which, let's try that. 2 times over square root of 2 over the square root of 72. Y'all good with that? Okay, so we can do it this way first. Now if we do that, now we have to simplify each radical individually, okay? So check this out. So the square root of 2 is still just going to be the square root of 2. Can that simplify at all? But can 72 be broken up? Okay, what can it be broken up to? Can it be broken up into a perfect square? What's the largest perfect square it can be broken up into? 36, okay? 72 is divisible by 4, but the largest one is 36, okay? So I'm going to write this as the square root of 36 times the square root of 2. Are you guys okay with that? Y'all good with me so far? Okay? So now this becomes the square root of 2 over, well guys, what's the square root of 36? 6 divided, times radical 2. Well guys, what's radical 2 divided by radical 2? Does that just cancel out? So we are left with 1 over 6. Alright guys? Now, I want to show you, if you had done this guy as radical 2 over 72, if we had simplified this before, then we would have gotten, we could have turned this into 1 over 36, because they're both divisible by 2, right? They're both divisible by 2. Now that's square root of 1 over the square root of 36. Well, guys, what's the square root of 1? 1. What's the square root of 36? 6. So you can get it either way. Do y'all see that? So when you are simplifying radicals like this, you can do it either way, where you simplify it before you separate them, or you can simplify them after you separate them. Alright, guys? I'm not going to lie. I think this one's easier to simplify before. Alright? The next example I'm going to give you, I think it's easier to simplify after. Alright? So, let's show you guys this. Alright, so let's look at number 6 here. This is our last example today. Alright? I'm going to give you guys the square root of 80 over the square root of 25. Alright? So, do you guys want to separate it first, just like we did up here? So this is option 1 up here, okay? So we're going to separate it first. Square root of 80 over the square root of 25. Well, guys, this is nice, because what's the square root of 25? Just 5. So now our bottom is just 5. Okay, now can we do the square root of 80 in any way? What can it be simplified by? Or what can it be a perfect square factor? Is 80 divisible? What is it divisible by? What's the largest perfect square? Ooh, 40 is not a perfect square. It is divisible by 40, but 40 is not a perfect square. 16, yeah. So 80 divided by 16 gives us 5. Lovely. So we're going to call this, so this becomes radical 16 times radical 5. Are you guys okay with that? Because 80 can be split, square root of 80 can be split into square root of 16 times the square root of 5. Well, guys, what's the square root of 16? There we go. So that's 4 square root of 5 over 5. And that right there is our simplified expression. Do y'all see that? So, let's see if it follows the rules. Does our radicand, the number under here, is that divisible by any perfect squares? No. Does the radicand contain a fraction? Is there a fraction in that radicand? No. That 5 is a whole number. And finally, are there any radicands or are there any radicals in our denominator? No. So we're good. So this one satisfies everything. Okay? Now, I want to show you guys what happens if you simplified before you separated your radicals. Okay? Last little method here. Okay? So 80 divided by 25. So guys, can we simplify 80 and 25 at all? Can those numbers be divisible? What is it going to give us? 16, right? Over 5. Are you guys good with that? That's divisible. Okay? Well, guys, we can now separate this into the square root of 16 over the square root of 5. Are you guys comfortable with this? Okay. So what is the square root of 16? That's 4. Okay? And then we're still just left with the square root of 5 on the bottom. Okay? So, what rule is this breaking right now? You can't have a radical in the bottom of, it cannot be in the denominator. So in order to get rid of a radical, how do we do this, y'all? Well, let's think for a second. If I have a square root of 3 times the square root of 3, what is that going to give me? Ooh, well, what's 3 times 3? So what's the square root of 9? Okay, let's see if that works for other things. If I do the square root of, let's say, 7 times the square root of 7, well, guys, what's 7 times 7? What's the square root of 49? 7. So, guys, in order to get rid of a radical, what do? We multiply it by itself. That's one way we can simplify it. So, guys, what I want to challenge you guys with is right here. We don't want this to be a radical. So we want to multiply it by square root of 5. But in order to make that a true statement, we're going to multiply it by the square root of 5 over the square root of 5. Because what is that? That's just 1. Right? So in order to get a radical out of your denominator, you multiply it by the radical over the radical. So guys, check this out. What we are left with when we do this is we have 4 on the top times radical 5, right, over, well, guys, what's square root of 5 times the square root of 5? 5. Is that what we got when we did it the other way too? It sure is. So, guys, if you are left, I'll put this on our notes here. So, guys, if you have a radical in the denominator, you multiply it by itself over itself. Does that make sense, guys? So you want to multiply it by itself over itself because that's just 1. Right, guys? So in this case, because we had the square root of 5, we did square root of 5 over square root of 5. If we had radicals, if we had square root of 3, we would do square root of 3 over square root of 3. Does that make sense, guys? Is that helpful to kind of see that there? So if you have a radical in the denominator, you can multiply itself by itself. All right, guys, in your final answer. So what I want you guys to do is I want you guys to go ahead and get out your Chromebooks, and we're going to get to work on our homework.